Okay, question 6, another tricky question, and actually quite similar to the trick that you needed to spot in question 5, was that this looks very similar to our double angle formula. Let's write out the formula again, just so we're aware of what it is, and hopefully that should help us work out how to progress. And remember, that's in your formula booklet. Well, if we compare the 2 with a 6, well, hopefully you can think, well, I want 3 lots of that. So we now have 6 sine theta cos theta. Well, that's fine. It's written out like this. So put simply, you can just say 3 sine 2x equals 6 sine x cos x. So our A must be 3 and our B must be 2. That was mainly just leading you into part B, which was a little bit more technical and did require your good knowledge of, hello Mark, a good knowledge of your angles, particularly with regards to radians. So hence or otherwise solve the equation 6 sine x cos x. Well, notice that's exactly the same as we had before. We're not going to be able to solve it like this, but we can solve it if we use what we did before, i.e. we've got 3 sine 2x equals 3 over 2, and that means if we divide both sides by 3, we have sine 2x equals to 1/2. Now, you should be well aware, because you've been practicing your trigonometric values, if you do inverse sine of a half, that gives us 2x is equal to pi over 6, and using our cast diagram, 0, pi and 2 pi, we've done the inverse sine and we got pi over 6. The other value of sine, which is going to give us the same result, is over here. This will be pi on 6, which means the other value for 2x is going to be 5 pi on 6. We don't want 2x, we just want x. So finish the question. Pi x equals pi over 12 and x equals 5 pi on 12. Well, the question has given us a range. Which of these values is greater than a quarter? Well, that's not pi over 12. It is 5 pi over 12. Is that less than a half? Half a pi? Yes, it is. So that must be our only solution.